The color average tool is used to check what color is present. The tool considers the hue, saturation, and brightness of each pixel within the tool window and outputs the overall average color according to the area. This tool is different from the color area tool in that it just indicates what color is present, not the amount of a certain color. You can see in the example below, if I have a tool window that is half red and half white, the color average will come out to be a pink shade. Let's go through another example. I'm going to use this color average simulator file to walk through step by step how to set up the tool and also explain how the color average tool and settings work. In my example, I'm going to be looking at paint swatches and I want to differentiate the paint swatches based off of their average color. Let's jump into sensor settings. Because I already have my master image saved in this file, I'm going to jump to step 3, my tool settings. I'm going to select Add Tool, go to my color tools, and then select Color Average. You'll notice it gives me a yellow box on my screen, and this is my tool window. You can also see I have a master M up here indicating what the average color is within my tool window. If I were to move this window, let's say to half on my paint swatch and half on the white background, you can see my master average color changing here. As I were to change the size of the window, you can see how that affects the master color. So that's just a visual of the color average tool and what it's seeing. But in my example, I'm just concerned with the color of my paint swatch. So I'm going to leave my window like so. Notice you can also change your window to be a circle, or you can even change it to be the entire field of view, which would be looking at this entire image here. I'm going to go back to a rectangle and leave my tool window like this. It's also important to note you can add a mask if you needed to hide a certain area in the middle of your window. You can do that with the mask function. The next thing is the limit adjustment, and this is just what will determine a good versus a bad part. So by default, it is 70%. Any color that the average color matches by 70% or more, that would be a good part. If it matches less than 70%, that would be considered a bad part. Now, at this point, my tool is complete. I am ready to hit OK and complete my program. So it's a very simple, easy tool to set up. However, there are some extended function settings that I'd like to discuss and go over. So the first is the color range settings. If I click settings here, I can adjust the sensitivity of my tool and what's considered good or bad. So I'm on normal sensitivity right now, and you can see I have a graph for the hue, saturation, and brightness here. If I change this to high sensitivity, for example, you can see that my thresholds for hue, saturation, and brightness all narrow down and become more sensitive. If I change this to low sensitivity, those thresholds will expand and my tool will be less sensitive. I can also change this to manual and kind of manually change what color would be acceptable. You can also see I have my hue, saturation, and brightness values of my master color, my master average color. So that would be the 32, 59, 169. I just have a simulator file, but if I had a IV3 connected and I was looking at my live image, it would also give me the hue, saturation, brightness of my live image. So I could compare my live image to my master and adjust my thresholds accordingly. So I'm going to keep it on normal sensitivity and just hit OK. But here's where you can make that sensitivity change. So the next is the specification method. If I hit settings, right now I am specifying my average color from my master image. However, I can also specify it from a direct input. So for example, if I knew the hue, saturation, and brightness for what I want my master color to be, for example, if I want it to be black, I can type in and directly input those values here. This might be helpful if I want my master color to be black, but maybe I don't have a black paint swatch on hand in this moment. So you can change it there, but in most cases you will be using the from master image setting. So that pretty much covers the extent of the settings. I'm going to hit OK and complete my program. And let's jump into the operation simulation to see how this tool would judge other targets that I have saved. So as you can see, I have some various colors saved in my program. And as I click on these, the tool that we just set up will be applied, and you can see my live image is this blue shade. I get a matching rate of 0% because this color is vastly different from my master, and so this would be considered a bad part. As I continue to kind of click through each image, that average color will update like so. Now it's important to note you can also export the HSV values of your live target to a PLC, and that way you can actually read the exact color that you are seeing as well and make a judgment in the PLC if you want to do it that way. So as you can see, it's able to correctly detect my swatch of the same color while differentiating them from blue, white, or black paint swatches. So I hope this video helped explain how to set up the color average tool and explain the settings and how it works. But if you have any additional questions, please give our tech team a call at 888-KEYENCE option 2 for tech support. Thanks and have a great day.